This Week in Virology, the podcast about viruses, the kind that make you sick. This Week in Virology, episode 173, recorded on March 2nd, 2012. Hi, everyone. I'm Vincent Racaniello, and this is TWiV, the podcast all about viruses. Joining me today from Western Massachusetts, Alan Dove.
Good to be here.
How you doing, Alan?
Doing great.
It's a crappy day, though, right?
It's a crappy day today, but last week I spent the week in Puerto Rico, and it was a gorgeous day every day.
That's right. You had a week. How was it?
Oh, it was lovely. We were in a little town east of San Juan that has a beach, and then right behind the beach there's a mountain with a rainforest on it. It's,
nice.
Yeah.
You know, I had a friend who was in Puerto Rico a couple of weeks ago. He came back with dengue.
Oh, dear.
It's endemic there.
Yeah. Well, we didn't get bitten by any mosquitoes, so I hope we don't come down with anything.
Yeah, he was covered with mosquito bites and had joint pains, went to a doc, and he said, yeah, did a little rapid diagnostic. You have dengue.
Well, it is a tropical island.
Yeah, well, there is dengue. There's no doubt about it. Well, welcome back.
Thank you.
Also joining us today from North Central Florida, Rich Condit.
Hi, everybody.
How are you, Rich?
I'm good. How are you?
You were having pizza withdrawal, right?
Yeah, it's really tense down here.
Want to explain?
So I had to even post that on the This Week in Virology website.
I know.
Our a local pizza joint, Satchel's Pizza, that everybody here knows and loves, had a fire in the kitchen, so they're going to be closed for 6 weeks. It didn't really burn down, but they did a lot of damage. Vincent has been there. We've talked about Satchel's on TWiV before. It is a destination. So everything will be all right. He'll get it back together. Satchel's will be back in good shape. I hope maybe you get some new ovens out of it or something. Though, actually, we were a little concerned that maybe if they change the kitchen at all, it'll impact on the pizza. Which
Never
would
know.
not be good. Right?
Could be those ovens that have just the right hot spots, you know. Who knows?
I think that pizza comes right out of Satchel's soul, so I think everything will be okay.
That was very interesting. Well, we've missed you for a couple of weeks. Welcome.
Yeah, I've been away for a while.
Welcome back.
Thank you.
Also joining us today, a repeat visit from Department of Epidemiology at the State University of New York, which is in Brooklyn, Michael Walsh.
Hi, guys.
How you doing?
I'm doing okay. I had fortunate that my son donated a cold to me, brought it home from his daycare, so I'm lugging that around with me today.
Great.
Well, at least it's not dengue.
Yeah.
Could be worse.
That's right. I'll take a cold over dengue.
Need to exercise your immune system. So you're okay after your landmark TWiV last time.
It was a blast. It was fun.
Guess your throat wasn't sore for a few days.
No, actually, it was okay.
Good. It was great. Got a lot of good comments about it. Well, we're glad you came back today. We had a couple of papers that deal with epidemiology, and we need your expertise. So thanks for agreeing to do it on short notice.
Happy to.
Also joining us today from the Department of Microbiology and Immunology right here at Columbia University, Ashlee Bennett.
Hey.
Welcome to TWiV.
I'm excited to be here.
Have you ever heard of TWiV?
I have heard of it a few times.
Ashlee is a PhD student in my laboratory here.
Yep.
This is insider trading or something like that?
Yeah.
It's okay. Is she in the TWiV studio there?
Yeah.
Right here, yeah.
Okay.
So, Vincent, you're getting soft in your old age. You're letting them out of the salt mine now.
Yeah. Well,
Yeah.
Really soft.
I really jumped on the opportunity to get out of lab for a couple hours. It's my main motivation for being here.
It's funny. Ashlee's got like coffee and food and papers and a laptop. You're ready to go, aren't you?
Yeah.
Be here for a couple of hours. Well, welcome, and just don't be shy. I know you tend to be shy. All right, today we have really 3 papers, and the first 2 are dealing with, of course, actually H5N1 influenza. And the first one I'd like to do, and these are why we need to have Michael here. The first one is from Wang, Paredes, and Palese. It was published as a brevia in Science Express, 23rd February. It's called Seroevidence for H5N1 Influenza Infections in Humans, a Meta-Analysis. And I think we may have mentioned this study a few times on TWiV, but now it's out and we can talk about it. It's one page. It's quite short, and it investigates the question of, are there people in the world who have been infected with a influenza H5H1 strain and are not dead or extremely sick? And the way the infection is detected is by taking their serum and looking for antibodies against the virus.
So in other words, is this a virus that just circulates out there and only occasionally hurts people, or is this a virus where the case fatality rate is really representative of what's going on?
Right, because as everyone probably knows, the WHO numbers are about 60% fatality rate based on their confirmed cases, but there's reason to believe that this is not correct. So maybe, Michael, you could tell us what is a meta-analysis in this kind of study.
So a meta-analysis is a technique that is used quite frequently, actually, particularly in the clinical trial setting. And typically the motivation behind doing a meta-analysis is to bring together different studies that are suitable to be brought together, and I'll talk about that in a minute. But it's combining studies to yield an overall estimate of the effect of exposure on outcome that you're looking at, or in the case of what we're looking at today, a combined point estimate. Okay, so a lot of times you will see in the literature various studies investigating a particular exposure on an outcome, and some of the studies may yield statistically significant results, finding, for example, that a particular drug treatment decreases a particular disease outcome by some measurable magnitude. And then other studies will perhaps not find as strong results, or maybe not statistically significant results, or in some cases they may be contradictory results. Okay, so finding the opposite. But one of the problems that plagues clinical studies, well, any observational studies as well, is expense. Okay, so you cannot have a study that oftentimes will give you enough statistical power to identify small or moderate differences in your groups. Okay, and so what will happen is an investigator.
It's the Brooklyn crime.
Yeah, exactly. We've got the level 1 trauma center right across the street. Friday is usually a little bit slow in the winter, so hopefully it'll be okay. So what an investigator will do, who's interested in this particular field, will try to combine these different studies to come up with an overall estimate of either an effect of an exposure on an outcome, or an actual point estimate. So measuring, for example, the prevalence of some disease or the incidence of some disease by combining different studies together. Okay, and there's a plethora of methods for doing this validly. Okay, you can imagine that it can get statistically complicated, because essentially what you are doing when all is said and done is combining different study populations. Okay, you're combining the patient population, if it's clinical studies, that are represented in these different studies into one overall clinical population. Or if it's observational, then you're combining different groups of people who are community dwelling into one overall population. And particularly if you're talking about different geographic locations and you're doing that, you have to be careful about how you combine those groups of people together, because they could be quite disparate, and that can influence your results. So the bottom line is that you do a meta-analysis when you have a body of literature, a series of studies that have been done, but these studies aren't really yielding together as a whole consistent results. Okay, so what you want to try and do is bring these studies together in a standardized analysis to try to come up with your own overall estimate. Okay, pooled estimate.
So it's like a review of the literature, but it's quantitative.
Exactly. Because you're actually physically combining the different study populations together, the individuals and the different study populations together to produce a new estimate. The question is, does the 800 people that came from this study belong with the 300 people from this study to estimate the prevalence or incidence of a disease or the effect of an exposure on an outcome?
So you said this can be done in a valid way, but we've talked about a number of meta-analyses on TWiV where the conclusions are not valid because, as you say, maybe the populations are too different and so forth. So there are good meta-analyses and bad ones?
Correct. And actually, one of the process is made a bit simpler here for the Wang and Palese paper because of the fact that they are simply measuring point estimates rather than effect
Can you
measures.
define point estimates?
Yeah, a point estimate is the estimate of the occurrence of a disease at a point in time or over a given point in time. For example, prevalence. Okay, prevalence of a disease, prevalence of HIV in New York in the winter of 2012 would be a point estimate of the prevalence. If you look at the incidence of HIV infection in New York from 2000 to 2012, that would be a point estimate of the incidence per that 12-year period.
Okay.
All right. So then, how do you do this? In this case, they were interested in looking at H5N1 seropositivity. So what would you do? The first thing, you would go to the literature and look at all the studies that fit those criteria?
Yeah, so you usually have to identify the specific key nowadays when you do one of these. You have to identify the specific keywords that you used in your PubMed search, and then this way it's reproducible. So anybody can go and take those keywords that you used to generate your list of studies, go to PubMed, and identify the same studies. And the idea is then you generate this list of all the possible studies that have been done, and then you have to go through each study and determine for yourself whether or not the study is suitable to be included in your meta-analysis. And what I was saying before about this being a little bit smoother of a process for this group because they're measuring point estimates, what you still have to deal with the variability and the variation differences in different populations. But what you don't have to deal with in this type of meta-analysis that is a real problem in other types of meta-analyses is covariance. Okay, and that's the type of problem that you deal with when you look at the effect of an exposure on an outcome. And a lot of meta-analyses do that. Okay, and it's very difficult to do that because now you're not just looking at how this one thing, in our case, the prevalence of H5N1 infection in humans, okay, you don't just have to look at how one thing varies within a population, but in those more difficult meta-analyses, you're looking at how in an exposure varies in concert with an outcome. That's covariance, okay, or correlation. You can think of it like that. And that's a much more difficult thing to ensure, okay, that you are validly combining populations.
Okay.
In fact, for TWiV listeners who've been around for just a little while, I think there was recently a discussion on here about the meta-analysis that Osterholm and his group did on flu vaccine efficacy.
That's right. Yep.
That's right.
And that's a case where you have flu vaccination, how many people got the flu, what kinds of morbidities did they get, a very, very complex meta-analysis.
Correct, yeah.
Now, when they do these meta-analyses, do they acquire the raw data from the prior authors?
Generally, yes. I mean, nowadays you really won't get. There's sort of a continuum of meta-analyses from bad to good, and the ones that are going to get published in good journals are the ones that are going to have all the raw data from the studies. Now, sometimes you can actually acquire all the raw data right from the published studies. And, for epidemiologic studies, if the study has been published well, then you should be able to do that. There shouldn't be any hidden information with respect to the study population. Nevertheless, sometimes, there may be additional information that you need. And then typically what you do is you contact the investigator, you tell them that you're doing a meta-analysis, and you request the missing data that you need to complete that accurately.
Now, do you have to contact the investigators regardless to get their approval to use their prior research in your meta-analyses, or do you not need their approval?
No, it's not required to contact them. A lot of times, if it's an important study that's being used, well, actually, I should say, in the meta-analyses that I've been involved with, we have contacted all of the investigators, whether or not one study was a key, was presenting key findings or not. So it is sort of good, it's good.
That's a good question. It seems to me like it would be at least a courtesy, and you might find out some stuff that's relevant.
Mm-hmm.
Right.
So in this meta-analysis, they say they found 19 studies where they assessed the serum based on what they call modified WHO guidelines.
Right.
So I guess that's a standard for saying this serum is positive, right?
Right.
So, and then you take those 19 studies, and then they also took another 10, I think, which the authors established their own criteria.
That's
for
correct.
Seropositive. So is this? Do you always have to follow what WHO says, or what? I'm sure this applies to more than just H5N1, right?
Yeah. So usually one of the big characteristics that is going to define comparability, is looking at how each study measured either how they assess the measure of occurrence, and by measure of occurrence in this case I mean the prevalence.
Okay.
And then if it's an inferential meta-analysis, then you're going to look at how they assess the association between the occurrence and the exposure. Okay, like a drug trial, for example. So they have a standardized process here, and that standardized process is that which was established by WHO. And they did an analysis that only included the WHO criteria, or the modified criteria, and then they also looked at those studies which had used their own criteria, as you just mentioned.
Right.
Okay.
So we should just point out that WHO criteria for being seropositive against H5N1 is either, one, the detection of a fourfold or greater increase in neutralizing antibody titer in paired acute and convalescent sera, with the convalescent sera having a titer greater than 1 to 80. So that means you have to get the person when they're sick and get serum, and then when they're better and get serum, right? Mm-hmm. Or 2, antibody titer of greater than or equal to 1 to 80 in a single serum collected at day 14 or later after the onset of symptoms, and a positive result using a different assay, like a Western blot or HI or whatever. So those are pretty stringent, right?
Yes.
Well, in both cases, you're talking about people who are symptomatic.
Correct.
Right?
Why would they need to take samples both when they're, really sick and afterwards if they're looking at serology?
I can let Michael answer that.
Why would they need to take during the illness and after?
Yeah.
As opposed to just after, if you're looking for the presence of an antibody.
Well, there's going to be a delayed response, immune response. So you may not actually have detectable antibody at the time of symptoms, at the time of infection. So you'd want to wait for the specified period after, for the so that the antibodies can become detectable.
Yeah. It's also a good control. So you have, the first time point, you have little or no antibodies, and it goes up in the same person. So
you have the individual as their own control. Exactly.
But you don't always get that, so that's why the second one. So, Rich, you had said it's both symptomatic. So the second one, I guess, the second
Day
one says
14 after the onset of symptoms.
Yeah, the first one just says paired acute and convalescent, but I assume if you're acute, you have some
But if you're
symptoms.
acute, that implies you've got symptoms.
Exactly. Yeah.
So that's interesting because I was looking at these as...
So that's where the modification comes in, to allow for the detection of asymptomatic infections.
That's correct.
Right.
Yeah.
We've modified the WHO criteria by eliminating the requirement that the study participants be symptomatic.
There you go.
Yeah.
Thank
So that's big time.
Yeah, it's pretty hard to catch people when they're in the acute phase anyway. That would make it a lot harder to
Sure.
do
Unless
a
they go to
study.
the hospital, right?
Yeah. to wait by the emergency room door.
And so really the question that they're trying to get at is, well, one of the questions that they're trying to get at is the criteria as they stand for the WHO criteria as they stand for detecting H5N1 in the community in humans, is it too specific?
Right.
Okay, is it not sensitive enough? So it's the difference between sensitivity and specificity.
Just as a side, it seems to me that you need a whole separate study on its own to really address that, right?
Absolutely.
Not just a meta-analysis, but maybe they suggest that that's what should be done. So they get the WHO criteria, they get 7,304 study participants, and then they say the range of seropositivity was 0 to 5.3%.
Right.
With one exception. And then they applied their meta-analysis to this, where they get then an overall positivity rate of 1.2%. So that's where you do some math, I presume. Is it just an average or?
Well, the math comes into more with the measure of uncertainty. Mm-hmm. Okay. And the measure of uncertainty, and you guys have all heard of confidence intervals, measures of central tendency,
right,
and the associated measures of variance that go along with that. Well, what's happening here is that they're applying a specific method for estimating the variability, okay, within and between studies, within and between populations, essentially is what it comes down to, okay? And so where the, for example, the application of the random effects comes to play is in the confidence interval. Okay, so if you look at the overall seropositivity rate of 1.2%, the confidence interval from 0.6 or 6 in 1,000 to 2.1%, that confidence interval is robust to, or in other words, our measure of uncertainty, okay, about that point estimate of 1.2 is robust, at least, to a certain degree, to the differences that could be inherent across those different populations.
So it could be as low as 0.6% or as high as 2.1. Okay.
Correct.
And then that's what the WHO-based assays. And then the non-WHO guidelines, they get 6,700 participants, 1.9% seropositivity, and then the confidence interval is 0.5 to 3.4%, right? Mm-hmm. Mm-hmm. So these are real numbers, right?
Correct.
And then they also broke it out into poultry workers, where they had 2,700 of them, and the rate is 1.4%. And then they broke out the 97 Hong Kong outbreak, because a lot of people think this is a different virus. So when they break those out, it goes up. The seropositivity is 3.2%.
Right.
Now, there's this one sentence at the end of the paragraph: studies after 1997 and that used WHO criteria show an overall rate of approximately 0.5%.
Yep.
So is that their bottom line, really?
So that's the bottom line. And the reason they're saying that this is the bottom line is because this is, essentially Osterholm's critique in his paper. I forget where that was published. Anyway, I have it right here in front of me.
In Bio, yeah.
Bio, yeah. That was a critique of an earlier publication by Wang and Palese, and basically they're sort of responding to that. Mm-hmm. And so what this last sentence is saying that, okay, fine, we'll take only the WHO criteria, and we will exclude any cases that could be attributed to the 1997 Hong Kong influenza pandemic or epidemic. And what we'll do is just do the analysis based on that much more stringent criteria. Mm-hmm. And what they still come up with, okay, is an estimate of 5 per 1,000. Mm-hmm. Okay, that's
0.5%.
Yeah. That's
so the only departure from WHO criteria is that they don't have to be symptomatic, right?
Correct.
They're still using the cutoff of 1 to 80 or so forth, right?
That's right.
So what does that mean, Michael? 0.5%.
Well, this is where it gets interesting, I think, because, well, first of all, what we can't say is that, okay, this means that there are 5 people in every 1,000 across the whole of Southeast Asia who are infected.
Right, because these are selected populations, right? I mean, they're talking about poultry workers or places where somebody had a diagnosed case of H5N1, and so they go in and study the whole population around them.
That's exactly right.
They are selected populations.
Exactly right. Yeah.
Right. So at the very least, we're talking about rural populations or chicken farmers or folks like that.
Mm-hmm.
Right. It's not the U.S., not New York City.
Which is still, I mean, if we're talking about Southeast Asia, that is not a small number of people.
It's not at all. And, what's interesting, some of these studies actually found that in the studies that were able to assess a range of exposure to poultry, that not all the studies identified higher levels of poultry exposure with associated with seroevidence for previous H5N1 infection in humans. Mm-hmm. So that was an interesting observation in a couple of the studies. Now, another thing that's interesting is that I went and actually looked at each one of these studies, and
holy cow, you did your homework.
I just wanted to get a sense. Well, I did this last weekend when this first came out, and I wanted to get a sense of how the quality, of these studies, and were they doing good shoe leather epidemiology? What were they doing in order to assess as many people as they could in a given population, and how were they defining these, and et cetera, et cetera. Okay, so the conclusion that I come to is really that for both the set of studies that found no prevalent infections, okay, or prevalent of evidence of past infections, okay, and those that did were done very well. All right, so they have included in this meta-analysis a set of studies that, as far as I'm concerned, are methodologically sound. Okay, so
right. One thing you just raised a point that we hadn't really touched on before, and that is that there's a significant fraction of these studies where a whole bunch of people were surveyed and they didn't find any evidence of H5N1, right?
It's correct. And in fact, there were actually more studies that found no seroprevalence than there were that found a positive seroprevalence. Mm-hmm. Okay, so nevertheless, all of the studies that were included in here were methodologically sound, and so I feel confident in accepting the results for both sets of studies, meaning that in some areas they identified prevalent infection, in some areas they did not identify prevalent infection. And one of the things that this tells me is that we don't understand nearly enough about the transmission of this virus within the birds population, and then how that translates into, for a few unfortunate individuals, or maybe not unfortunate if they're actually, not symptomatic, because some of them weren't, how that translates to bleeding over into human infection. Okay, and go ahead.
So are the data good enough so that you could go back now and separate out two sets of data, one where infections were discovered and one where they weren't, and ask what the differences were between those populations?
I don't think so.
Or are the numbers too small for that to be useful?
I think the numbers in terms of the...
Now you're doing covariance, I suppose. And
yeah. Well, in fact, some of the studies did do that. They tried to... In fact, if you look on the bottom of the first column there, the study that found 11.7% positivity, that study actually looked at... I'm sorry, not that study. It was the study that had the low threshold for identifying seropositivity. I think it was the cats. Is that might have been the cat. Yeah, I think it was the cat study. They actually looked to see what risk factors may be associated with prevalent infection, and they found, as I mentioned, they didn't actually find that increased poultry exposure was associated, but that things like not having indoor plumbing was associated with exposure. And then another study found that exposure to outside water sources, bodies of water in the landscape, okay, that was associated with increased risk for infection. So there may be a prominent role for virus that's shed by birds in stool into water, makes its way into water sources, and then humans have contact with those water sources and potentially become infected through that route. We just don't know, And one of the issues that is we have to really try to understand. We have to understand two issues. What are the dynamics of transmission in the bird population? Okay. And then what are the dynamics that need to be just right for an infection to go from the bird population to human, adjacent human population? Okay. Mm-hmm. And there are a whole lot of things that are, in fact, someday we should have a show and we'll just talk about infectious disease epidemiology and how we measure things like the force of infection and the basic reproductive number or reproductive ratio, because these things are all relevant. I mean, the ways in which the bird communities are in contact with each other through trade, because if we're talking about poultry, then the movement of birds through trade can be very important. But then there's also the wild bird community and the influence of migratory patterns and how those influence contact rates among the birds. And then what's the bridge, from birds to humans? So anyway, the sort of step back and look at the big picture for me from this meta-analysis is that we cannot say, as I said before, that if you take just the most stringent criteria, we cannot say that there are approximately 5 infections per 1,000 people across the whole of Southeast Asia. Okay, that wouldn't be appropriate based on these data. But what we can say is that using very strict WHO maintained criteria, we can say that there are some communities in Southeast Asia and across a wide geography of Southeast Asia that wherein a relatively large proportion of people are infected with asymptomatically infected with H5N1. And when I say large, to me 5 per 1,000 is large. Okay, and we're talking large populations too overall. So
right.
So a number of people have said, well, okay, so there's seropositivity, but in the end, it's probably still higher than any other influenza virus. But it seems to me you can't really tell until you do more studies, like more serosurveys, right?
Absolutely.
One thing I'd really like to see someone, explain for me is, I mean, we try to compare this to other numbers. We have a case fatality rate that's been quoted for H5N1. There's a case fatality rate that's been quoted for the 1918 flu. There's a case fatality rate that's out there for seasonal flu. And all those numbers are going to be dependent on how you define the cases, right? And yep. I'd like to see a good comparison of those, so I know what numbers I can compare. My guess is that in the case of H5N1, we just don't have enough data to come up with a reasonable number.
That's correct, and I think there's actually in not just in the media, but probably in the research community as well, there's a preoccupation with case fatality. There are other parameters that I think are more important with respect to the impact of an epidemic. Okay, for example, if you have, just to make it as simple as possible, because we don't have time to go into defining all of these concepts like force of infection and things like that, but just to put it in simplest terms, if you have an infection that spreads very, very rapidly and effectively through a population, take, for example, measles. Okay, it's highly infectious. It spreads quickly. It doesn't have nearly the case fatality that something that gets a lot of media attention. Perhaps H5N1, but perhaps not. But something that, like Ebola, for example. Okay.
SARS,
yeah, good example. So, but what makes measles more dangerous is its ability to transmit in populations. Okay, so I would hold that measles is far more dangerous than at the population level. I'm now speaking, of course, at the population level. At the population level, measles is far more dangerous than Ebola, okay, or SARS for that matter, because it is when you have a large proportion of susceptible people, that infection is going to make its way through that susceptible proportion of that susceptible group of people much more efficiently and quickly. And as a result, even though it has an overall, smaller case fatality rate, even in the best of circumstances, when the case fatality, like in the Western world, the case fatality is about 1 per 1,000 or so. But if it ranges between that and say 5% case fatality, because you're going to have so many more infections, because it's much more effective at being transmitted, then at the population level, at the public health level, that translates to being a much more severe and serious infection. Okay,
right.
than one that has a case fatality rate of 50% or 80%.
Right. If it kills everybody it infects, but it only ever infects 10 people, then it's not as big a concern as a virus that's going to infect everybody in the country.
That's exactly right.
Right.
Yeah,
and the point is that we don't know enough yet about the transmission dynamics of avian influenza, even in the bird population. Forget about what could be going on between birds and humans, to have any sense of what those more important population parameters might be.
So the assumption is that if H5N1 acquired the ability to transmit among humans effectively, the assumption is that the fatality rate, whatever it is, would not change, and that's just not right.
It's correct.
I think that it will undergo genetic changes, which will most likely impact the fatality rate.
Not only that, if you look at specific locations following the 1918 pandemic, and you crunch some of these numbers, looking at different parameters that measure things like the force of infection and the basic reproductive number and how that changes over time, and the growth rate of the infection in the beginning of the epidemic relative to later, what you find is that there are many places in the world where a large proportion of the people were not susceptible at the first major wave of that pandemic because of cross protection from exposure to similar strain virus previous. Okay, and so that was the case. And there's instances of that being the case from various sites around the world. So, even in what we have in terms of our documented history as being the worst pandemic of influenza, okay, up till now, when we typically think naively that the whole population was susceptible, it wasn't. All right, there were still large chunks of the population that were not susceptible, at least not completely susceptible to the high virulence that some were.
Sure.
Okay.
So let's do one more thing with this and then move on to the other paper. Is it fair to say that these data suggest that the WHO fatality rate is too high?
I would say yes. I don't think I have to equivocate at all with that. I think because there is clear evidence that there are asymptomatic infections occurring at least in some communities in the world where this seems to be the biggest problem, i.e. Southeast Asia. Okay, so given that's the case, we know for sure that that denominator, that's the one that's used, the 500 plus hospitalized cases, we know for sure that that is not going to be reflecting all of the symptomatic cases, because you don't just have, you have a spectrum. You're not going to just have some completely asymptomatic cases occurring in communities, and then extremely virulent pathogenic infections that are killing people.
Mm-hmm.
Period. There's no, it just doesn't work like that. There's going to be more of a gradation. And so since we're able to see from these combined studies that there are indeed asymptomatic infections, I think it's safe to conclude that that denominator is too small.
Right. I've also been I've gotten a couple of emails from Osterholm about this, and the last point that I made in this discussion was, regardless of whether the official WHO rate, the 59% is off by one order of magnitude or 12. The objection that I've had to this all along is that it's the wrong number to put front and center in front of the public.
Yeah.
Well, in that vein, let's move to the second paper, which came out at MBio also last week by Osterholm and Kelly. It's called Mammalian Transmissible H5N1 Influenza Facts and Perspective. And the part that I'd like to deal with is their own sort of meta-analysis of the sero data. And I'm going to just read the conclusion. Then Mike, maybe you can go through it a bit. They conclude, given the available seroepidemiologic data for human H5N1 infection support the current WHO reported case fatality rates of 30 to 80%. 30 to 80%. So they have done their own, and they conclude that it's all wrong, and it's still 30 to 80%. So, Mike, why do they come up with a?
It's funny that you mentioned that, because I have that circled and a line drawn next to it saying they do no such thing. I mean, I have no idea why that sentence is in there, because
they come up with the same number, don't they?
Exactly. If you look, it's they have, instead of 0.5, they have 0.4.
0.47 or 0.49, I think, are the two numbers that they...
0.47. So in total, it's the last sentence of the first paragraph in the second column of page 1. It says 3 of the 13 studies reported serologic evidence of H5N1 infection. In total, 26 or 0.47 of the 5487 participants in these studies were found seropositive for H5N1. That's the same. That's the same thing that is being reported. And now this particular paper was in response to an earlier, much briefer paper by Wang and Palese that I think they did a sort of a quick and dirty combination analysis to get something out there.
Yeah, it wasn't really a meta-analysis. They just picked studies, and they even picked studies that they now would even agree. There was a study that came up with like 10% or something like that, and they would even argue that study is using assay criteria that are not sensitive enough.
Right, absolutely.
Not sensitive enough.
Right. So now in this paper, in one breath, Osterholm is agreeing with Palese's current number, and then a few paragraphs later is saying, so this supports 30 to 80% case fatality rates.
Yeah, so what I don't understand as well is really what that has to do with the 30 to 80% case fatality rate. I mean, to me, what it says is, okay, I mean, I'm just going to reiterate what I said before. I mean, you have a proportion, and to me, it's a proportion of substance, because it's 5 per 1,000, and when you have, a large population, that actually translates into something. 5 per 1,000 of the people who are asymptomatically infected. You don't just go from asymptomatic infection then to lethal symptomatic disease. There's got to be a gradation there. So how they're saying, when they themselves are identifying approximately 5 per 1,000 asymptomatic infections, how they can say that the available epidemiologic data for these infections support the case fatality rate of 30 to 80%. I just don't see what's the basis of that connection.
So as far as I can tell, after coming to this 0.47%, he then goes on to say that one of the studies, which was done in Thailand, was they used a low cutoff, only 1 to 10,
right.
And then he says that that this is probably false positives. Okay. And then
that's the one with the big number.
That's the one with the big number. Then he moves on to the 13 studies where the WHO criteria were used, and he said 5 have problems because they're also too low. And he basically throws them all out, saying these data support the concern regarding the false positive results in the Thai study. So he's throwing them all out, essentially, because he doesn't believe them because of the low cutoffs. Now, it doesn't make sense to me because if they're WHO approved, that's 1 to 80. So he's saying they're not actually following the WHO guidelines. That's why he says these are all really negative, and I don't believe any of it. Michael, is that how you read this?
I'm just looking at that one. Excuse me, that one sentence. The 5 studies, which included the 26-29, found that no participants had evidence of previous infection based on WHO criteria for serologic confirmation, and only 13 had neutralization titers between 1 to 10 and 1 to 40. I mean, see, you know what? I don't understand why he's throwing out the first sentence, actually, where he says of the 13 that use the WHO criteria, only 5 reported the titers. Mm-hmm. But if they're using and maybe this is just restating what you just said, if they're explicitly saying that, okay, we're using WHO criteria, that implies that they were over the 1 in 80 cutoff.
Right.
Right.
So it seems pretty cavalier to throw those out. I mean, you know what it seems like is a bias.
Obviously, because this Osterholm is actually one of 15, I believe it was 15 members on the voting board for the National Science Advisory Board for Biosecurity. So, I think it's almost unprofessional that he was the author of this paper, because he's basically just supporting his own decision. I think that if they really wanted their own separate analyses done, they should have had somebody who wasn't on the voting board do it.
Mm-hmm.
Well, even as we discussed before, even if you don't follow the WHO guidelines and say, he's missing the asymptomatic cases in his analysis because he's only following the case definition. And as we said, that's probably an acceptable omission.
Another problem I have just further down this column, it's in the third paragraph, about 2/3 of the way down. He says that periods of observation of exposed persons by health authorities have lasted for up to 6 months, after the initial follow-up period. To date, this type of targeted surveillance has not uncovered additional cases of mild influenza-like illness caused by H5N1 infection. So what he's saying is, these communities that had established the contacts were followed, and we didn't see any illness, so nothing happened.
But that's the point.
That's the point.
We're looking for asymptomatic infections.
That's one thing, right? And then the other thing is that how well do you think that 6 months of follow-up surveillance for all of these potential exposures is going on? I mean, in a country that has resources strapped, are they really able to go out and follow all of the exposures for 6 months? I mean, it just doesn't seem. Yeah, it seems unrealistic.
Also, we know it doesn't transmit among people. Those are not the individuals to look at.
Right.
You want to see people who have contact with poultry,
right,
or water contaminated by poultry, whatever. So.
And the thing that I find really, it really rubs me the wrong way, is that after this statement, that is, to date, this type of targeted surveillance has not yielded anything. He has a citation, but the citation is not the data that were generated from the surveillance, which is what it should be if that's the claim you're making. Instead, it's just the WHO resource protocol, or the WHO protocol for doing follow-up.
Yeah.
Right.
Yeah.
Okay. So
that's right. Yeah.
I don't like that at all. I mean, that's very.
At any rate, he comes up ultimately, regardless of all this, he comes up with the same number as Palazzi, right?
Yeah.
Same number. It's just a different perspective on the same number.
Same number, but he doesn't believe it, basically.
Right. He comes up with the same number and then throws out all the studies that went into generating that number.
So, Michael, as far as you can tell, there's no reason to throw out those studies, right?
No. And I looked through every one of those things, and I thought they were all methodologically sound. Now, of course, you can question those studies that had the low titer threshold. Okay.
Right.
The low titer threshold for determining seropositivity, but there was only one study where that may have had a big influence, and that was the cat study. Mm-hmm. And there, aside from that, I don't see it really being much of an influence. Yeah. Okay, in the studies that remained, it may have been an influence in that study, I have to admit, but in the rest, I don't see it as being a big influence.
So at worst, we should just go out and do better studies and understand that there is some level of seropositivity. We need to know exactly how much and where. But to conclude that it's 50 to 80% fatality and that we should therefore be making vaccines and doing preparedness isn't really correct, right?
Exactly. And I think if there is a take-home message here, well, there has to be a take-home message. It is that we cannot. we have a set of studies that identify no prevalence, okay, based on seroepidemiology, and then we have a set of studies that do identify, and those are, for the most part, legitimate, well done, well executed, population-based studies. Okay, so because of this, what we do know is that there are some communities out there that have asymptomatic infection. We absolutely cannot conclude, okay, even though there are some studies that show no infection, that no asymptomatic infection exists. We just can't do it, okay? These data don't support that. They may not support that there is, ubiquitous asymptomatic infection all over Southeast Asia, okay? But they do support that some exists in some communities, okay? And that's enough to say, well, hey, look, going back now, taking a few steps back and saying that denominator that you have that only looks at the most severe cases may not be right, because we do know that there are some asymptomatic cases. So we expect that there's a gradation between those folks and the folks who are the sickest, who end up in the hospital and unfortunately dying.
So we probably don't need to be terrified of this virus.
No. I mean,
although it's worth remembering that it does, in some probably tiny minority of cases, it does kill people. Mm-hmm. So that it is appropriate to work with this in, say, a BL3 facility, because you may be one of those unlucky people who gets infected and gets killed. Just from a workplace safety standpoint, you want to keep that locked up. Mm-hmm. But probably not worth, as you say, putting a lot of money into developing vaccines.
Right, and I think the whole vaccine argument here, here's a whole section on the vaccine is kind of a red herring. I mean, this also seems to be in part response to the other paper by Wang and Palese, because I think they had mentioned in it, they had like a one sentence at the end of that other publication that said something about vaccines, okay, and antivirals, okay, right. So oseltamivir, and what he's saying, he goes on this long argument about how we don't have enough, and how the vaccines that we currently have aren't going to be effective against an avian influenza pandemic. Well, of course we know that. I mean, that's right. Of course we know that. I mean, we need new vaccines every year. Okay, the vaccines that we had from last year don't work next year. So we know that we don't have vaccines stockpiled against a potential avian influenza pandemic. But that's not the question. The question is, what's the prevalence of asymptomatic infection? Period. What is tacked on here at the end with this vaccine section just seems to be feeding into this scare tactic, I think. I mean, that's my sense anyway.
Well, he has kind of made a living on this scare tactic when he published his book in 2001. So it's not very surprising.
Well, I wouldn't, in Osterholm's case, I wouldn't say that there's much of a monetary agenda going on here. His primary job is he works as a public health researcher. I mean, that's where his paycheck is coming from. And I don't think anybody other than, a few top authors like J.K. Rowling are making a whole lot of money off books these days.
Nevertheless, his approach seems to be bypassing the science. I just don't understand.
He does seem to have a very strong bias, but I suspect that it's a case where he simply has a strong belief that is perhaps based on his own personal fear.
It's a bias, right?
But that's a dangerous bias.
That is a dangerous bias, and it's one of the problems in these types of clumping and meta-analyses is, if it's not done carefully, then these biases can get transmitted right through.
Yeah. What I find interesting is, as you mentioned, Michael, he'd published a meta-analysis of someone else mentioned, of the flu vaccine efficacy, which we talked about.
That's right. Ellen, you mentioned that.
And he's very supportive of that, right? So anyway, I think we've talked about these enough. Anything else before we move on from anyone? I find it's unfortunate because I think that the meta-analysis shows there's some seropositivity out there. We should investigate it and not move forward blindly, assuming that it's not correct. And I don't think the Osterholm view is correct. I don't want to bash him. I know that, but I'm just saying his conclusions don't follow, as you've heard. Mm-hmm. All right, Michael, do you want to depart?
I will. It's been a pleasure again talking to you guys. And one of these days we have to talk about transmission of infectious disease, because that's where things get really fascinating.
Definitely. We'll have you back. Yeah. Sure. Thanks so much for taking your time to do this.
Oh, no problem. Thanks, guys.
Thanks, Michael.
Bye-bye.
See you.
Okay, take care.
So has this H5N1 stuff made the 6 o'clock news?
I don't know. I don't watch it.
Neither do I. That's why
well, what's happened with the story for the most part is it has exceeded the public's attention span. So this is no longer a top news item anywhere outside of the science press.
Although the Times is still running articles, but I guess that's not mainstream anymore.
No, the Times is mainstream. What drives news coverage on it at this point is things like the biodefense meeting that just happened down in D.C., where the panelists, including Osterholm and also Tony Fauci and Ron Fouchier was there, they all spoke, and I think we're going to talk about this Times story that came out of that event.
Right.
But it's not the constant drumbeat of, hey, this horrible virus that kills half the people it infects has been made in a lab. That all has died down.
Well, I have to show you this is a good time to bring this up. One of our listeners, Dorian, sent a photo that he took in Paris last weekend of a news kiosk. It's in French. On a créé le virus le plus dangereux du monde. So I don't know if it's died down yet. At least the popular press is still doing it. I got a call last Saturday from, I think, CBS News, and they wanted me to go over there and, record something about this. So I don't know. I think it's still out there.
Wow.
So this week there was a ASM biodefense meeting where, as Alan said, Fouchier, Osterholm, Fauci, and Keim were talking, and this was covered in the Times. And I listened to Fouchier's presentation, which I found very interesting. So if you remember, in the very beginning, I think last fall, it had been reported that his ferret-passaged H5N1 could transmit among ferrets, and also it killed them all. But what he said the other day at the biodefense meeting was that this modified H5N1 virus, it has mutations in it. He didn't say what they were. It will transmit among ferrets, but it doesn't kill them. It doesn't transmit to all of them, so it's not very efficient. And the viral titers that are produced in these ferrets are low, and they're delayed compared to other viruses.
And if the ferrets have been exposed to any other flu strain, they develop no infection at all.
That's very interesting.
That's very interesting.
Yeah.
So these are really different from what he said before. So I went back and looked at a summary of his Malta meeting presentation as reported by the New Scientist. And that article said 5 mutations in just 2 genes have allowed the virus to spread between mammals. What's more, the virus is just as lethal despite the mutations. And Fouché is quoted as saying the virus is transmitted as efficiently as seasonal flu. So I don't know what the difference is between what he reported and back in September and what he reported this week. So there's a big disconnect, and many people are noting this. And in fact, Fauci, who was there, said, let's get the NSABB together and look at this again.
How can he say that it's transmitted as efficiently as a seasonal flu? Like how, what did he do to come to that conclusion? Because he's using ferrets in cages. I mean,
what he actually says in this new presentation is that the transmission is in fact not quantitative. Doesn't have enough animals. He can't really put a number on it. But then he, as Vincent said, measures viral titers and with respect to time. And not all the animals get infected. The titers are not as high. They come up later, and so that this implies that it is not as it doesn't, from those criteria, it doesn't look as transmissible as some of the other viruses that are readily transmissible.
Yeah. So he based it originally on comparing with a seasonal flu infection of ferrets and the number of ferrets that got it by air and how much virus they shed. But as he said the other day, it's not quantitative, so that wasn't a correct statement to make.
I thought he was comparing it to the human influenza transmission.
No, not in people. You couldn't do that, right?
Yeah.
And so even the wild type and he specifies his wild type H5N1 strain.
Right.
Even that strain introduced intranasally at some reasonable dose doesn't actually kill the animals. I think he has to inject it, and I forget whether it's IV.
No, intranasal, it will kill the first one.
Well, no, it'll if you inject a massive titer,
right, that'll kill it.
Intranasally, you can kill the ferret.
10 to the 6th, kills 2 out of 2, the wild type, right?
Right.
His mutated H5, same dose, kills 1 out of 8.
Right.
In the original inoculated animal. And then when it spreads by aerosol, it doesn't kill anybody.
Right.
So his title is dead or moribund, so it either kills them or makes them very sick.
So my understanding of all this is that the transmission does not appear to be as good in ferrets as seasonal flu. Not only that, but this transmissible virus is reduced in virulence relative to what he started with, correct?
Sounds like it.
That's my understanding from the presentation,
And Rich, by the way, yes, when you put it intratracheally in ferrets, both this mutated strain will kill them all intratracheally, right?
Right. So that's giving a huge dose intratracheally.
Right, which is not the way we get
Right.
the virus. So unless maybe you're holding a dead bird and you inhale deeply, maybe you get an intratracheal inoculation.
Well, if you stick the bird down your throat and then inhale deeply, it's going to...
So there is one situation I thought of that may explain all of this.
Ozzy Osbourne? Oh, no, that's bats. We'll get to them in a moment. Sorry.
So back in September, he had mutated H5N1 so that it recognizes alpha-2,3 sialic acids, the alpha-2,6 sialic acids, the mammalian. Put 3 amino acid changes. He passed it 10 times in ferrets, and then he said that virus passed efficiently through the air and killed all the ferrets. Okay? He said he identified 2 additional mutations in those viruses. And back in September, he said the next step is to put them 5 mutations into a fresh H5N1 virus. Maybe that virus is what he described on this past Thursday, and maybe those mutations aren't enough to do what he originally found. You guys understand what I'm saying?
Yeah.
Mm-hmm.
Yes.
I'm giving him a benefit of the doubt, because why would he report different results? It's puzzling, isn't it puzzling?
Yeah.
I don't know what's going on.
Yes, it's puzzling.
It's
and
very
it'll be
puzzling.
nice to see everything.
And I was frankly quite annoyed at some of the phraseology he used, but more especially the general tone of the latter part of the meeting, where there was a lot of blaming the media. for how this
Yes.
had all gotten misinterpreted,
Yes,
and Fouché even says there are some misunderstandings about these data.
He said it got out to the press, which I found amusing because he originally talked to the press, didn't he?
This is an unpublished paper, people. Where did this information come from?
Yeah, the authors.
Maybe he didn't realize the furor it was going to cause.
Yeah, I think that's probably true.
Well, he made some pretty inflammatory statements in the original Science Online article.
Yes.
You know, he said it was a dumb experiment, the most dangerous virus you could make. I mean, that's not smart.
Maybe
No.
he was trying to make it onto Fox News.
Well, you know, last thing about this, he was really nervous at this ASM biodefense. He was sweating and his voice was shaky. Did you notice that, Alan?
Yes, I
Yeah.
did.
I wonder why. When people do that, it's weird. Something's up.
Well, I mean, come on. This is somebody who's been in the news in not an entirely positive way for the past month. I would kind of be surprised if he weren't nervous speaking on this occasion, especially since he knew he was going to stand up and present data that pretty much said, sorry, everybody, this wasn't a big deal.
Yeah, I mean, when you have the New York Times calling you irresponsible and saying that you're putting the world at danger, I mean,
Is that what they said? Yeah.
I think something to that effect, yeah, that the research was irresponsible, and
Oh, initially, yeah.
Yeah. that's a pretty hefty charge.
When the WHO is calling a meeting to talk about your work and they're not giving you a prize, I mean, that's a bad sign.
All right, so we'll see. This is obviously not over, right? It still has to. And we'd like to see the paper to maybe that would sort out, because the paper is supposedly going to be what he submitted originally and what the NSABB saw.
Right.
And made them scared. So stay tuned. Let's talk about a paper also about flu, but which is less controversial and I think really interesting.
This is cool.
And Ashlee, this is up your alley. This is virus discovery. Well, your former alley anyway.
Yeah.
We should say Ashlee used to work in the Lipkin lab, right? Is it okay to say that?
Yeah, it's okay to say that.
Cool.
I am a proud Lipkin Lab alum. It was a fun place to work for a couple years. I worked as a technician there for 2 years before going to graduate school. It was a pretty exciting environment, I will say.
Cool. Well, this paper is from CDC, Guatemala, the CDC of Guatemala. And basically it's called A Distinct Lineage of Influenza A Virus from Bats in PNAS. And the idea here was really to look for influenza viruses in other species. We know that all of the known influenza virus, HA and NA serotypes, can be found in wild birds and various mammals, of course, but where else? So they designed Pcr primers to pick up basically a really conserved part of the influenza virus genome that encodes one of the polymerase proteins. It's called PB1. And then they looked in fruit bats in Guatemala, which they captured. They captured 316 bats from 8 different places, and they did rectal swabs.
Sounds like fun.
I don't think it's so hard. You get the bat in your hand, you swab it, and you let it go, right?
I think they're pretty feisty.
Yeah?
Yeah, Dr. Epstein, Jonathan Epstein, who I think is at the Conservation Consortium, he worked in the Lipkin lab for a while when I was there, and he collected bats and would take samples for them, and he described it as not being very easy.
They are wild animals.
Yeah, and you have to use nets to capture them. It seemed like it was quite a process.
We talked with Eric Donaldson before about this. Remember, he and Matt Freeman had a project to look at the virome of bats caught in Maryland. You guys remember that?
Yeah.
Mm-hmm.
So they were trapping them and sampling them. I think they got some rectal swabs and some.
I think they were mainly taking stool samples, which
So
is
I
easier.
think-
Yeah.
I
that's
think
right.
I think they made their job a little easier here because it says after the bats were killed,
Oh, yes.
Oh.
a complete necropsy was performed on all bats in compliance with approved field protocols. It's not clear to me that they killed all 350 bats, but they killed a certain fraction of them.
Right.
So,
These are little yellow.
That does take the fight out of them.
right.
They're little yellow-shouldered bats. I like that name.
Yeah.
I have this image of yellow shoulders. Anyway, 3 of them were positive for flu sequences. So they then went on and looked in other organs from these animals. and some of the organs were positive as well. So they say this suggests the virus is replicating in them rather than passing through the digestive tract. But it seems to me so a lot of this paper is based on the idea that this is an indigenous virus to bats. But I don't know about you guys, but I'm not compelled by that evidence that this is actually replicating in bats. What do you think?
Wouldn't you have found it more frequently?
In different bats, you mean?
Yeah.
Yeah, 316. So of the other available specimens, liver, intestine, lung, and kidney, and an oral swab, the 4 tissue specimens were positive, but the oral was negative. So that's why they think it's infecting.
Right, and I gather these are fruit bats. Yeah. So it's not that they're going around sucking blood or chowing down on insects. And it's unlikely that this flu virus came from fruit.
But I don't know. I think we still need to see if it's in other bats to make sure that it's a bat virus. Because
I think, in fact, I think later in the paper they say a seroprevalence study is on their agenda now.
Cool. That's good.
So I did look up some information on these bats, and they're cited as being frugivorous, which apparently means that they prefer fruit, and the vast majority of their diet is fruit, but they do occasionally eat insects. Could that make any difference here?
Are there any insect flus?
Not that I know of.
Yeah, I don't know if it...
No, not unless the insect picked it up from something else,
Yeah, I think, I mean, it's not definitive finding it in the other organs and not the oral swab, but it's good to see that they don't just find it in the digestive tract.
So they then sequenced...
one other thing that was a little puzzling to me, though, is since this is a mammal, I was kind of surprised that they were looking at rectal swabs rather than, say, lung.
That's
Good
true.
point.
Yeah, that's right.
We know it's a GI virus in birds, but
sure.
I would have gone for a tracheal lavage or something, and I probably wouldn't have found the virus. So there you go.
So they ended up sequencing the entire genome.
Right.
And Rich, maybe you will appreciate this. So they did next generation, Illumina and 454, and they verified it by Sanger sequencing.
Right, I saw that.
Isn't that cool?
Right.
For us old guys, we like to see that even the next gen has to be verified.
That's right.
So it's clearly an influenza A virus by alignment. It's got 8 segments. It's got all the signatures of influenza A viruses. They give it a name, A-BAT-GUAT-09. The neuraminidase is weird. It's got a lot of gaps compared to all the others. But this,
the neuraminidase doesn't fit anywhere. It's really out there. I don't think they can't really even decide whether that's A or B, right? It's
it's really diverged.
Yeah.
But basically, based on all the phylogenetic studies, they say this is probably a new hemagglutinin subtype. So there are 16 known. So this would be H17, which is interesting. And it's probably old. It probably arose long before, say, A and B viruses split up. But what I found was cool. They couldn't grow it in embryonated chicken eggs and in several mammalian cell lines, including bat cells. They weren't able to propagate it. So I guess they took some fecal sample, which was RT-PCR positive, and tried to propagate it. Mm-hmm. But, of course, what they will do is make the whole genome in plasmids and see if they can get infections. Personally, I would take this virus and pass it in ferrets. Try and grow it.
But then you couldn't get the paper published.
That's right.
Yeah.
They did one interesting experiment where they did a little virology experiment where they make a reporter where they take luciferase and they put the non-coding sequences of the viral RNAs on either side, and then they put this into cells which are expressing the minimal functional polymerase complex. It's 4 different proteins, and so then you can tell if that reporter replicates because you get luciferase, and it does replicate. So this is in a human cell, so this thing can replicate in the human cell. And they also say that this bat polymerase will recognize a human influenza A virus RNA in the same kind of assay. So that's kind of interesting.
Right. So at the transcriptional level, the molecular level, the bat proteins are cross-reactive with the human cis-acting sequences and vice versa. They did the experiment both ways.
Right. And they go into some discussion about the divergence and the amount of diversity that you see of the HA and the NA versus the polymerase genes.
Right. Yeah, the NA is way out there, as they say.
Yeah, it's interesting because the hemagglutinin clusters quite clearly with influenza A. The neuraminidase is out there,
from
and
Mars.
The other, from Mars. The other 6 segments, the polymerase segments and NS and M, are, yes, they cluster best with A, but they're really outside of the major group of all the other A viruses.
Right.
They're just barely A. They're not B. So this is a virus that's really very significantly different than the other viruses that we know of that segregate in birds, and has been around. It's probably ancient.
Yeah.
One thing that's cool is they look at the HA at the receptor binding pocket, and they say it doesn't look like alpha 2,3 or alpha 2,6 sialic acid binding pocket. It looks like a distinct sialic acid or a distinct ligand preference, they say, which would be interesting. Maybe it has a very different receptor. And in that case, the NA would be different because the NA would cleave off the receptor from the cell surface. So it would be cool to express the HA and try and find out what the receptor is, and also to express the NA and see what kind of enzymatic activity it has.
So now this is something that people do all the time, right, is look for influenza viruses in all sorts of animals. And the dogma, as I understand it, is that the natural reservoir for influenza viruses is birds, and occasionally you get interspecies transmission, so they show up in pigs and horses and humans and that kind of stuff. So this is a unique finding. This is a virus that they haven't seen in birds that's in some totally different species, bats, right? So
yeah, that's right.
Yeah.
As flu goes, this is unique.
It's really cool. And remember, Eric Donaldson's bat scans, which he did in Maryland bats, didn't pick up any influenza viruses. I looked at that last night. So it may be specific to certain kinds of bats. But what they say is interesting is what other animals have influenza viruses in them. And that's an interesting question.
Right.
So why did they choose this particular species of bat in Guatemala? There's a lot of bats, lots of places.
Somebody wanted to go to Guatemala, I suppose.
Well, they're in Guatemala. This is a field office in Guatemala. So it may just have been a case of, hey, we're here, we're virologists, probably. Let's see what viruses are in our bats.
They don't really answer that. They just say they use this real-time PCR degenerate priming to search for novel flu viruses from fruit bats in Guatemala. So I guess, they had an agreement with. They're probably doing this with lots of other places that have bats, I would think.
Or this could even have been piggybacked on some other study. Maybe they were somebody was catching these bats for some other reason, wildlife biology study or something, and they figured they'd go after this.
I'm thinking that in the U.S. you couldn't go out and trap 350 bats and kill them.
Yeah, it probably had to be a non-endangered bat.
Yes.
Yeah, the Donaldson study, they released them all. That's right. Are they endangered in the U.S.?
Some of them.
Some of them are.
Okay,
especially now with the white nose syndrome.
Yeah.
So, Ashlee, you said the Lipkin lab was doing some bat stuff?
Yes. Well, in conjunction with Jonathan Epstein, who did he was actually a veterinarian, and I forgot exactly what he was looking for, but he was looking at bat samples. And as a matter of fact, one of the most disgusting things I ever had to deal with when I was in the labs, he brought back, as well as collecting samples from the bats, he brought back these, they're called like bat ticks, but they actually look more like spiders. And he said that when he worked with the really, really big ones, the ones that look like flying teddy bears, the big flying foxes.
Flying foxes.
And he said that they're just covered with these like bat tick things, except they have long legs. And he said as soon as you catch one, they just climb all over you.
Nice.
And so he actually collected some of these nasty-looking bat ticks, which were really, really big and looked like big spiders, and asked me if I would help him extract the any possible virus genomes from them to look at them under our mass tag technology. And they were just really, really nasty. I remember trying to grind up these nasty insects, and it was just like, wow.
They're not insects. They're ticks are they're not arachnids either. They're another.
They're nasty.
Yeah.
So the Lipkin has published one paper about a corona that they found in bats in Nigeria, and the interesting thing is one of the authors, Ruprecht, is also on the paper, the flu bat or bat flu paper that we just talked about. So there you go. All right.
Sorry, ticks are arachnids. Yes.
Is that right? Ticks are arachnids. They got 8 legs.
They have 8 or 10.
Oh, they're cute. You're right.
What, the bats?
Yeah.
See their yellow shoulders?
Yeah.
Look at that. That's kind of neat. Yeah, that's got to be the episode picture, don't you think?
Yeah,
Sure.
I like bats.
It's very cute.
So I was going to ask you, about this bat influenza virus. I mean, we all know, I believe it was Nipah was transmitted through bats. I believe what happened was, bats were living in close quarters with pigs. They were defecating in the area of the pigs. That allowed pigs to pick up the virus and eventually was able to get into a form that could infect people. Mm-hmm. With this new influenza virus found in bats, are there any worries about the same thing happening in swine farms in South America? I mean, is this going to be the next 5 o'clock news thing?
Are there swine farms in Guatemala?
I would
Sure
assume so.
there are, yeah.
I would assume so.
They didn't seem to be worried because it's so diverged.
Right.
On the other hand, it does, it works with human virus segments, so who knows? I would be doing all sorts of experiments to see whether it's compatible. Maybe it can reassort with human strains, who knows? Because maybe it hasn't so far because they're isolated and we don't get much contact with them, but it's an interesting question. Wouldn't you want to see if this virus could reassort with a human strain?
Yeah.
Absolutely.
Yeah,
well, in fact, they kind of are trying to get at that in the paper.
Yeah.
They say it's with the polymerase experiment, that shows that it's a possibility that it might reassort with the human strain.
I think you could say, do a reconstruction experiment. You take 7 segments from a human strain and 1 from this one, see if that works, and increase the numbers. All kinds of interesting things to address that, whether they are compatible genetically with human flu viruses. I think that's very cool.
Yeah.
All right. One more thing before we move on to email. And I think a listener was asking about this, and Alan can summarize it for us. It's an article in The Scientist called Elsevier Abandons Anti-Open Access Bill. So I think we briefly mentioned this before, that Elsevier was... I
always thought it was Elsevier.
Elsevier? Yeah, well, I can't pronounce things right. A bill had been going through the House to limit the NIH's ability to have recipients of their grants deposit it in an open access website, all their publications. So, Alan, what's this about?
Yeah, so this is an ongoing battle between open access journals and traditional journals. And the two business models are the traditional journal gets subscribers' fees and also advertising, and that's how they fund the operation. The open access model, they also do advertising, but they instead of charging subscribers, they charge the people who are submitting the papers. They charge a page fee. So it costs a few $1,000s to publish an open access paper if you're the researcher. But then once you do that, everybody can have access to the paper. In the closed access model, only subscribers have access to the paper. So a few years ago, the NIH implemented a policy where they're big fans of open access because it's got a lot of advantages. It allows the people, the taxpayers who paid for the research, to have direct access to it without subscribing to these journals. And their policy is that you have to submit your article to the what's the full text PubMed? The
PubMed Central.
PubMed Central. Within, is it 6 months now? Yes. Within 6 months of its publication. And so that essentially means that it becomes open access 6 months after it's published. Elsevier is the 800-pound gorilla in closed access publishing. They publish a bazillion different journals, and they have whole different business units doing different things. I actually, at one time, I worked for some of their publications that are that are targeted at audiences in drug development labs, and so they have all these sorts of things, trade journals and business journals and things that they publish, but their scientific publishing is built on this subscription model, and their subscription rates are notoriously high. So if you have access to, let's say, Cell, from your university library, it's because your university library writes a huge check to Elsevier every year, which gives access to Cell and a bunch of other Elsevier journals. That's their business model, and they are scared of open access because they think that it's a threat to that business model, and I think they're correct. Rather than adapt to it, their strategy this time around was to have their congressman introduce a bill that would force the NIH to abandon this policy, this 6-month deposited in PubMed Central policy.
So it's all about a business model, basically, right?
Yes.
Right.
This is very typical of what you see of large companies' lobbying efforts when they're built around a particular approach to business and they see that it's threatened. This is, I think, economists call it rent seeking, which is an attempt to tilt the playing field rather than to try to compete on market basis. Elsevier was supporting this bill, and then somebody pointed out, hey, we could do something about this as researchers. And the something was to boycott Elsevier journals. So there was this petition circulating online for people to sign up and say that they would not submit papers to Elsevier journals and would not be peer reviewers for Elsevier journals. And it got off to kind of a slow start, but then hundreds and hundreds of researchers started signing on to it. And largely in response to that, Elsevier decided, we'd better backpedal a bit on this. So they went ahead and abandoned their support for this bill, and it's dead.
Mm. Okay, well, sounds nasty. There's been a lot of boycotting and bad words. And
what do you think is going to happen, Alan? It sounds to me like they're going to either have to change their business model or become Kodak.
Gosh, I hope they don't become Kodak, which, by the way, just canceled its slide films today. I was very sad about that. Yeah, they're going to have to come up with a better way to pay the rent.
Right. The internet is just too slick. I don't think
it's not even so much the internet. It's this open versus closed access approach,
right.
And they could perfectly well publish open access journals using the page charge model that has been shown to be sustainable. In fact, it's to the point now where I get, and I'm sure Vincent and Rich, you get emails every week from people who are starting up these sort of spammy journal of obscure genome mutation analysis or whatever. And the whole model of those is just to get people to submit whatever crud they're going to submit and get the page charge.
The journal of who gives a crap.
Exactly. Yes. And so there are now bunches of these things springing up. And the reason that's happening, that I'm not saying that's a positive trend, but the reason it's happening is because you can actually make a living in open access publishing.
Mm-hmm.
It's funny, a couple of weeks ago at the New York Academy Forum, there was a representative from Nature there and Science, and someone asked them, if you guys hadn't tried to publish this H5N1 paper, would someone else have? And the Nature person said, oh yeah, there are plenty of these open access journals out there. She said, they have websites. I don't know what they are, but they would have probably... So she was basically making fun of this whole thing. They have a website.
Yes.
All right, so we've had a few emails from a number of people about this. So that's what it is, and seems to be done for now, but I'm sure we haven't heard the last.
No, Elsevier is an absolutely massive publishing empire. I think they may be the oldest publisher on the planet, because it's Reed Elsevier, and they were started in, the 1500s or something. And they're huge, and they've got a lot that they would have to change if they were to move all their academic publishing to this model, and they're reluctant to do that.
Yeah, most of the journals I click on, I end up at an Elsevier site. So they own
and it's not cheap
ones.
Either.
No,
they'll charge you like $35 to see a paper if your
Yeah.
university doesn't have a subscription.
Yeah,
I mean it's crazy.
This will impact your career, Ashlee. You will encounter this longer than any of us will. This is the future. So,
it may be settled within the next few years, I think.
Maybe. All right, let's do a few email here. We got an email from Glenn Rawle, whose paper we discussed last week on 172. He wrote, my very favorite title was The Super Caltech from a couple of weeks back. It takes either a very creative or very sick mind to come up with something that amusing.
Sick.
And we have
Definitely sick.
the creative
Sick.
Alan Dove here who makes up those titles. I thought you would be complimented by that.
Thank you. Yes.
The next one is from Dorian. Oh, I already mentioned this. Dorian sent us a picture of the billboard in France, so we'll put a link to that. The next one's from Barney, who writes, Dear TWiVists, my primary reason for writing is just to thank you for all the countless hours of entertaining education. If you feel that it would be interesting for TWiV, it would be great if you could address my personal story, and it may stop others making the same mistake. I have never been immunized with MMR, measles, mumps, rubella, and have had all three of the illnesses. Due to a bad case of mumps, I have permanently lost the hearing in one ear, thankfully not more. When talking to my parents, they said that the MMR autism scare was not the primary reason for not immunizing. They seemed to believe that having measles would have given my immune system a workout. In my case, this has not worked too well. However, I would like to know if there is any truth in this. What does not kill you will make you stronger theory. My ex-family and their current doctor supported and encouraged their choice. I am pro-vaccination in general, but do not blindly support all vaccines. I hope this is not a too immunology-based query to be addressed on TWiV. Thank you, and keep up the weather-based introductions, bad jokes, general informal chat, and educating the planet. Barry is a TWiVite from Cardiff.
I think vaccines give your immune system a perfectly reasonable workout.
Yeah.
Without killing you.
The problem with the workout theory is that a lot of these diseases can be problematic. As you saw, you got deaf in one ear. These measles can kill you. It's not worth taking the chance. You get plenty of workout from the environment.
And kids at the age when they're getting these vaccines, as any parent can tell you, their immune systems are already getting plenty of a workout.
Right.
You send the kid off to daycare, and you will immediately encounter every infectious disease that is known to man that's not vaccinated against.
Yeah. If we're using the workout analogy, I think that getting a vaccine is like the difference between running on a treadmill and running down the highway.
Yeah.
And trying to cross the highway.
Good analogy.
That's good.
Well, one thing I think about occasionally is that when you die, if they just leave you there in the garden, you rot pretty fast, okay? Mm-hmm. And it's interesting to think that every instant our immune system is preventing that from happening, okay? So your immune system is getting plenty of a workout all the time. Don't worry about it.
Mm-hmm.
Yeah.
As for blindly supporting all vaccines, I never met a vaccine I didn't like. I think we don't have all that many, and the ones we do are really good.
Well, of the approved ones that are part of the regular series, I would agree.
Isn't that what he means?
I assume. Well, if you start talking about some of the vaccines that are maybe given to the military.
Okay. I agree. I think just the routine ones that we get, childhood vaccines, the few adult vaccines, I think they all have a good purpose.
Oh, they not only have a good purpose, but the ones that are routine are some of the best products ever manufactured.
Yeah.
And they've all been vetted pretty well.
They've been vetted, and quite millions of people have gotten these. It's really, those are extremely safe. The only ones that I would be concerned about would be the ones that are maybe for special niche purposes that in some cases can have side effects.
They're always a good idea, though.
Yes. Yeah, and in the case of, I gave the example of military vaccines, and there's some concern about things like the anthrax vaccine and even the smallpox vaccine, since the one that we give is still the original, very primitive one. But if there's perceived to be a real risk of being exposed to those agents, you would still rather face the risk of the vaccine than the exposure to the agent. So it's just the same calculation at a different level.
Hey, Ashlee, you're missing your seminar. Do you want to leave?
Okay.
You don't have to. I was just joking, actually. I think you'd rather be here, right?
Yeah.
This is a seminar.
You bet. It's better than the seminars.
It's more informative.
Alan, can you take the next one?
I can. Alice writes, TWiVers, just listened to your really in-depth review of Contagion on TWiV. I thought I would let you know about a short conversation I had with one of the co-stars, Bryan Cranston, who played a military character named Lyle Haggerty. I haven't seen the movie yet. I got this from IMDb. In November, Cranston came to the State Department, where I work, to film some scenes from an upcoming movie called Argo. After he finished his scenes, he hung out with us for a little while. Very nice guy. I mentioned that my son had seen Contagion and that he'd liked the movie. When I said this, the effect was pretty dramatic. Cranston got real serious, practically did a full-body shiver, and said that after he did Contagion, he became very wary of touching door handles or anything else. It really had an effect on him. He said it really makes you wonder about what's on surfaces that might be dangerous. I didn't know what to say. All I could do was agree with him because what he said was true, even though a person shouldn't worry about it to excess. He probably should listen to TWiV. Maybe he'll feel better. Anyway, great review and love TWiV, TWIP, and TWIM. Keep up the good work.
I think that he should not have worried about surfaces.
You're interacting with surfaces all day long, every day. We're surrounded by bugs. Yeah. We got bugs inside and out. Don't worry about it. But we're designed to deal with this.
This happens pretty commonly with people who first encounter microbiology.
Yeah, that's true.
Yeah.
That's suddenly, oh my God, everything is creepy. Everything's got all these things crawling on it. Ah!
Yeah, you're right.
After reading this email, I think that the makers of the Purell hand sanitizing stuff should have just set up a little shop right outside the movie theater.
It's true. It's funny, Ashlee, but when I was at the New York Academy meeting, and of course Ian Lipkin was there, and someone came up and introduced himself, and he went to shake Ian's hand, and Ian said, no, I just washed my hands. I was really surprised at that.
Yeah. When you're a student and you first start studying microbiology and you learn about how there are microbes everywhere, just all over your skin, all over your eyelashes, like you're constantly exposed to stuff, I feel like you have to make a decision when you encounter this knowledge. You can either choose to be extremely paranoid, lock yourself in a bubble and become a hypochondriac, or you just kind of have to choose to get over it.
Our bodies are covered with microbes. All we're going to do is give each other our own flora.
Well, and the thing to do is for people who are first encountering this information, if you just tuned into TWiV and now you're really freaked out, for example, ask yourself, you've lived your life this far and everything seemed fine, and now what's changed?
Yeah.
This stuff was there before. You just didn't know about it.
You've already been exposed.
The only door handles I don't particularly like are the ones in bathrooms, because
public restrooms.
Public restrooms. People don't have good hand hygiene. And you can imagine that handle is covered with fecal contamination, which may have a norovirus in it. But what can you do? You got to get out of the room.
Yeah. Yep. I try not to touch my eyes after holding on to poles in the subway. Yeah. But that's mostly just out of concern for like a Pseudomonas or
issue. Yeah. Rich, can you do the next one for us?
Sure. Freddie writes, "Hello there, TWiVers. My name is Freddie, and I run a software company in London. I came across your wonderful podcast on Stitcher by accident back in November and have been hooked ever since. Listening to your witty discussions of contemporary science has opened up a whole new world of knowledge and discovery that I previously assumed I'd shut myself off from by not studying science at university. I work long hours at my company, but whatever free time I have is invariably spent watching Vincent's introductory virology lectures. Vincent, thanks so much for putting these online. I finished the 3-lecture introductory series over Christmas, and now I'm tackling the 26-lecture undergrad series. When I'm done, I intend to work my way through the graduate series, and in time, I plan to make the switch from working with computers to working in biotechnology. This is such a fascinating area. With computers, our knowledge all proceeds from first principles, but with biology, it's like we're reverse engineering an advanced alien technology, which is really exciting. I like that.
Yeah.
I hope to one day program living organic systems, much as I now program software systems. I just finished listening to your last podcast, which ended with an email from a listener who complained about the tone of your discussion about the NSABB and their treatment of the H5N1 issue. I just wanted to say that I had completely the opposite reaction to that listener. I felt your discussion was completely fair and reasonable and that there was nothing remotely hubristic about it. It's true that I've never heard you guys get stressed out about an issue before on TWiV, but scientists and lovers of truth and reason as you are, that is completely reasonable. Excuse me. That's right.
Yeah.
Sorry. If you're going to get indignant about anything in life, then scaremongering and groupthink are good things to take a stand against, and I applaud you for being outspoken about your very reasonable views. Science and reason may have a foothold in the Western world, but the notion of scientific impartiality has been under sustained attack of late, and it's become acceptable to criticize a politician for being too intellectual. It will be a dark time for all when science and truth are subordinated to fear and prejudice. Scientific openness is an important issue, and you're absolutely right to feel the way you do and speak your minds about this. You were big to apologize and see things from the other listener's perspective. If only self-criticism and open-mindedness to other views were more common in the world today. But I personally don't think you had anything to apologize before. Compared to all the phony sensationalism that often dominates popular culture and political decision-making, I found it profoundly refreshing to hear you guys getting passionate about something that really matters with the facts on your sides. It may be true that in an open debate, reason will eventually win over fear and prejudice, but not if lovers of reason fall silent because they don't want to offend the scaredy cats. So don't ever feel you need to be polite and silent in the face of nonsense. Listening to that episode made me feel passionate about this issue as well, and I spoke with several friends about it. That's how good ideas are spread, and the tide of fear is held at bay. I suspect that the vast majority of your listeners would agree. All the best, and thanks again for the wonderful podcast.
Wow.
There you go.
Good letter.
Thank you.
Yeah.
Really well done. I like this idea about knowledge and fear and all that. That's great. It's pretty eloquent there.
Fox News just lost another listener.
Well, I must say that, I have to say at this point that after that, the episode in question was 169. I personally felt somewhat uncomfortable by the tone of that conversation. And I wrote you guys about this.
Yeah.
I think it's important to stick with the science. And it's not like we can't, have opinions about stuff and that kind of stuff. But I think it's important to try and avoid personalizing stuff too much. There was a great Scientific American blog by Christine Gorman after the National Academy of Science meeting, where she's got a couple of good ones here. She says, "Scientists behaving badly, in my experience as a journalist, often suggests a lack of either evidence or of consensus in the field." There's an understatement. And she talks about ad hominem attacks, which I had to look up, right? Which is an attempt to negate the truth by negate the truth of a claim by pointing out a negative characteristic or belief of the person supporting it.
An attack on the person instead of the argument.
Yeah, right. And there were what she was talking about is some of the behavior at the that meeting of the New York Academy of Sciences, and I agree that shouldn't be done. And we all have to avoid that.
It's funny. She came up to me after the panel, and I was complaining about those kind of attacks. And I said, I don't know why some people have to make these. And she said, ad hominem attacks. I said, yeah. So she put it in. I think we try to stick to the science. Right. We can get passionate, though. It's okay.
Right. And I think, I think it's important to recognize what has happened here. The NSABB was charged with the task of specifically of looking at stuff for possible dual use. They flagged this. It created a big stir. That went to the World Health Organization. The World Health Organization said, we think that this problem, as if I understood it correctly, we think as a global body that with a few modifications and clarifications that this probably ought to be published. And now with some modifications and clarifications, some of which we talked about in this episode, Fauci is saying it ought to go back to the NSABB. So this has precipitated a global discussion on an interesting and probably important area of science or science and and society that needs to be considered.
Yep.
So it's all good. In fact,
and we probably did get a little more agitated than we strictly needed to. For me, as soon as you start tinkering with freedom of the press and free speech, I get all prickly.
Sure.
Yeah, censoring science is a big deal.
Yeah, no, I think we all feel that way. All right, let's do these last two emails. Next one's from Josh. Dear TWiV doctors, regarding the situation with the NSABB, I heartily defend the derision that you heaped on the Michael Osterholm and the NSABB and disagree entirely with the letter from Joe, the lawyer. I am not a scientist, but from what I know, it's not the motives of the persons involved that matter. It's the science. They either follow the science or they don't. If they do, then they are fine, and if they don't, then they deserve the same treatment that is reserved for homeopathic doctors. Just because Mr. Osterholm is sincere doesn't make him somehow above criticism. Saying we know but we can't tell you to serious researchers is an outrage, and they deserve whatever they get. If they don't like it, well, how does that phrase go about the kitchen and the heat? P.S. Look forward to the show every week. All right. Ashlee, would you like to take an email? Do you have them in front of you?
Sure.
You can read that last one.
So Paul writes, Hi TWiVers. I've been listening to TWiV since last October and love it. While listening to the discussion about the single virus genomics paper on TWiV 171, and having read the paper several months ago, it struck me that I would get even more out of TWiV if I knew the papers that you'd be discussing for the upcoming TWiV. I would bet that there is a subset of listeners who would download and read the papers before listening to TWiV, or leaf through the papers as you are discussing them. What do you think? Thank you for all the great podcasts, Paul.
I don't think that's a bad idea.
I think it's a good idea.
Yeah. I mean,
as long as we know far enough in advance, and we stick to what we post.
Sometimes we change it at the last minute.
You've usually got it figured. Yeah, sometimes you change it at the last minute. You usually got it figured out by about Wednesday.
Yeah.
Soon enough for Thursday night cram night.
So how should I do this? Would it be just a tweet or a Google Plus, or should I have a page on the TWiV site that I list them?
What's that thing that you did recently? That was some sort of feed that.
Yeah, that's a news feed. I could set up one of those for the papers.
Right.
The other thing to keep in mind is this isn't a live podcast, and so you could always post the papers even today.
Oh, that's true.
And then by the time you post the podcast,
that's true.
And as someone who's been a regular TWiV listener for years, and I often listen to these podcasts while I'm out running or something, sometimes it is hard for me to follow along in detail with the discussion of a paper when I haven't seen it for myself. And in some of the podcasts, I've gone back and looked at the paper before continuing to listen to the podcast. Right. You can get more out of it that way.
At some point, we're going to be live,
Really?
Yeah, I want to do that someday and have listeners asking us questions in a chat room and that sort of thing, but we're not there yet. All right, we'll figure out how to do that, Paul. That's a good discussion. Let's do some picks. Ashlee, what is your pick?
So my pick of the week is the Ask Science subreddit on the website Reddit. For those of you who don't know, Reddit is a user-generated content site that's kind of considered to be the front page of the internet. People submit articles and you can upvote or downvote them. And they have a section called Ask Science where people can submit a science question, and then they have panelists who are certified scientists in that specialty who answer them. So if you go to Reddit and then go to the Ask Science subreddit, you can read a lot of really interesting questions. And I even looked at it today before doing this podcast, and there were 3 virus-related questions that made it to the front page. One person was asking, how does rabies travel along nerves? And another person asked, if I moved from Seattle to Boston, would I be exposed to a different set of common cold viruses and therefore get sick more often? And so the only people that can answer these questions are panelists who have at least a master's degree of knowledge in the topic. So it's kind of neat to see what the general public is curious about.
Some of the questions here are great.
Yeah.
Yeah.
When one is decapitated, what brain functions actually remain momentarily? Do you actually have a few seconds to think about it? I've often wondered that myself.
Here's one for Alan. If neutrinos do not couple to the Higgs field, where do they get their mass? You know that one, right?
Yeah. I'll submit an answer to that right away.
Cool, but Do you hang out here, Ashlee? Is that why you know this?
I'm probably going to graduate a year later because of Reddit.
That's
There's
funny.
also a subreddit on funny, where people submit funny things, and a section called Aw, where people submit pictures of cats and puppies and all kinds of cute things. It's like crack for me.
All right. It's better than crack then.
Yeah.
Thanks for that. Michael sent us a pic. He wrote, I noticed no one has ever chosen Health Map. It's an ID surveillance project, and more specifically, the associated iPhone and Android app outbreaks near me. I think we have.
Yes, we did. We did at least the iPhone app. I had that on my phone.
It
Yes.
doesn't hurt to pick it again.
Nope.
So that's Michael's pick. Alan, what do you have?
I have. My pick is someplace I just went to last week, the El Juncke National Forest. If you ever get a chance, this is a really cool place to visit. It is the only tropical rainforest in the U.S. National Forest Service, and it's located in Puerto Rico, about a half-hour drive east of San Juan. San Juan's very easy to get to. Pretty much any flight to or from the Caribbean is going to go either there or pretty close to there. It's a big transfer point and all that. So if you're planning yourself a vacation and you want to go someplace easy to get to in the Caribbean, this is a good pick. And it's this mountain, El Juncke is the mountain. It rises right on the coast, on the northern coast of Puerto Rico, right outside a town called Luquillo. And Luquillo also has a couple of the best beaches in the entire Caribbean.
Neat.
So if you go there, you can go and hang out on the beach, and then you can go and hang out in a genuine tropical rainforest where you can climb up a mountain and into the clouds, and you can go hike and swim at the base of a waterfall and do all sorts of cool things. And it's pretty much an old growth forest that's most of it has been preserved the same way for the past several centuries.
Should try to catch a few bats next time you're there. And get some samples.
Yes, if I'd known about this paper, I would have tried to grab a few bats.
Can't really do that in a national forest, can you?
No, I don't think so. Not without a permit.
The anvil, it means. El Juncke.
Yes.
Okay, cool. Rich, what do you have?
Okay, this is a little redundant, but I wanted to pick it anyway. It's the actual podcast that we've talked about, which was the panel discussion of the NSABB's publication recommendations for the H5N1 research. This occurred at an ASM meeting entitled Biodefense and Emerging Diseases. And as we've said before, it was chaired by Paul Keim, who's the chairman of the NSABB, and had as panelists Ron Fouché and Anthony Fauci and Mike Osterholm and Bruce Alberts. And you know, if you really want to see all of these people in action and what they have to say most recently about all of this, I thought it was a really complete, a nice thing. I watched the whole thing. So there it is.
Good. Yeah, It's good to have that in the record. My pick is called the Journal of Global Health. And this is an effort carried out by undergraduates at Columbia University. And actually at the New York Academy meeting a few weeks ago, a number of the people who were involved with this came up to me. We had a conversation. And so it's very interesting. They have a website, and they also have a journal that they put out, a paper journal, in fact. And their goal is basically to try and make a grassroots movement for public health activists to build a dynamic community that interacts and talks about global problems.
Great.
Cool.
So check it out. They also came and did a podcast with me. It's about a half-hour interview, which is also up there as well. So check it out. Give them some support and see what they're doing. I think it's an interesting idea.
Excellent.
Journal of Global Health. We have a listener pick of the week from Judy. She writes, a listener pick since I know you all really enjoy the visualization of science. It's from the National Science Foundation, the International Science and Engineering Visualization Challenge. So these are, I suppose, it's a contest, right? And to visualize various things, like first place, metabolomic eye. And honorable mention, microscopic image of trichomes on the skin of an immature cucumber. people's choice, etc. So very pretty and very beautiful images here. Tumor death cell receptors on a breast cancer cell. These are illustrations, photographs, posters, graphics, interactive games, and so forth. So thanks for that, Judy. Judy is our high school teacher and lover of TWiV, TWiP, and TWIM. Thanks for that. And you can find TWiV, of course, at iTunes and at the Zune Marketplace, or at twiv.tv. Consider subscribing in iTunes, and if you enjoy it, go over and leave a comment. It helps to keep us on the front page of the directory over there, and that's how more people discover us. We also have an app for your iPhone or Android device. You can find that at microbeworld.org. We love to get your questions and comments. Please send them to twiv@twiv.tv. I want to thank Michael Walsh again for joining us. You can find him at the Germlines podcast on iTunes, and he also has a blog called Infection Landscapes. Ashlee Bennett, thanks for joining us.
It's nice to be here.
Do you have an online presence?
I've never been on Facebook, I'm proud to say, but I am on Google+, and I have an email.
I think you're working on a podcast, aren't you?
I am. Me and my friend Pat Gordon, who is a student here in the biochemistry and genetics department, we are working on a basic biochemistry podcast geared to people who are not biologists specifically, but would like to know more about it. And we've recorded one podcast, and we're going to be doing a few more here in the coming weeks. And we plan to set it up when we have at least a few recorded and ready to go. It's going to be called Biochemistry Revealed.
Nice.
Cool.
Great.
Look forward to it. When it's out, we'll plug it for you.
Yeah.
Make a pick of the week. Alan Dove, where can people find you?
Oh, well, they can find me all sorts of places, but the easiest is alandove.com.
And the El Juncke Forest.
Yes.
Catching bats.
Good to have you again.
Good to be here. Always a pleasure.
Rich Condit cannot be found, but he is at the University of Florida, Gainesville.
Right, that's the best place to find me. And ticks have 8 legs.
Yes, I confirmed that as well, yes.
It's a good episode title.
8 nasty
It
legs.
doesn't have anything to do with anything. VacciniaModel.com. I don't know if I told you this, Rich, but in one of the grants I saw a couple weeks ago when we were on study section, they used a figure from VacciniaModel.com.
Ah, good.
Isn't that
Excellent.
cool? I was looking. Someone next to me was looking at a grant, and I saw one of your pictures there. They're very memorable.
All right.
Thanks for joining us. Good to have you back.
Great to be here.
I'm Vincent Racaniello. You can find me at virology.ws. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.